Recording. Okay, so welcome to the second talk of this 2025-2026 edition of the AAAC Seminar. And it's my great pleasure to welcome today Jonathan Gratch, Professor Jonathan Gratch, Jon for most people, I guess, who is going to talk us about the social functional view of emotion recognition and analysis. But I'll just he's really well known to everyone, so he doesn't need an introduction. However, I'm still going to read a little bit of a bio that we put here on the website. So he's a research full professor of computer science and psychology at the University of Southern California and director of the Virtual Human Research at the University Institute for Creative Technologies. He finished his PhD in computer science at the University of Illinois in Urbana-Champaign in '95. And since then, well, he's done lots of research in computational models of human cognitive and social processes, in particular emotion. He played a big role in the humane network of excellence that is at the origin of the AAAI Association. He was editor-in-chief of the IEEE Transactions on Affective Computing, associate editor for Affective Science, Emotion Review, and former president of the Association for the Advancement of Affective Computing. He's a fellow of AAAC and the Cognitive Science Society, and still he has time to give a talk from time to time. Okay, so Jon, the floor is yours. Please go ahead.
Yeah, thanks, Lola. Yes, I've been at USC for like 30 years now. So I guess the one big change I want to announce is that I'm actually moving starting August 2026. So I'm taking a position at Vanderbilt University. It's part of their College of Connected Computing, and we're trying to build up a computational psychology, social science program here. So if you're a student watching, apply now. So I'm gonna talk about my background is in both psychology and computer science, and I'm going to try to bring both of those perspectives and some insights over the years towards how people in affective computing are approaching the problem of emotion recognition. And particularly in this talk, I'll focus on the face. And I'll sort of start by giving a straw man view of how emotion recognition is typically done in affective computing. And it's actually, although not everyone realizes, it's grounded in psychological theory coming back from Paul Ekman's work and his predecessors. You may have heard Paul Ekman just recently passed away. And you can think of Paul Ekman's theory is essentially, if you've seen the movie Inside Out, and in fact, he was a consultant on that movie. The idea is that we got these little guys in our head called emotions, and they fight for control over our body. And let's say if joy takes over control, then our behavior is colored by that control. So she shows, you'll see people show facial expressions like joy, and they talk in a more excited way. And if we can use machine learning from those external manifestations, we can basically recover which of those emotions is controlling that control panel. And so that theory comes with certain assumptions that expressions of emotion reflect some activation of an underlying and often viewed as discrete biologically evolved state, which is actually created to prepare our body to respond to a complex, uncertain environment. And these expressions typically are viewed as involuntary, although you can try to cover it up. They will leak out through things like microexpressions. And therefore, observers, when they look at our expressions, they can recognize and correctly label the underlying emotion that we're feeling. And thus, that emotional state is predictable from the morphology and timing of facial expressions alone. So that's what's sometimes called basic emotion theory. And that theory is manifest in the way most people in effective computing approach the problem of emotion recognition. So the standard approach is you'll collect some corpus, say, of facial expressions, typically out of context. And so, for example, here you see a woman's face, and I want you to, you're going to see a little video clip, and I want you to kind of think and reflect on what you think she's feeling. So you see that kind of video, and the standard approach would be we would upload that to a bunch of annotators over the web. Maybe they're in India, and those annotators will label it, and there'll be some distribution. In this case, we uploaded this video to Mechanical Turk, got 40 people to rate it, and 31 of those 40 people, 78% said joy. So typically, what do we do with this ambiguity? Um, Traditionally, we just ignore it and take the majority vote, although that's beginning to change in the field. So we'll label this joy, and now we can do supervised machine learning, and we can learn to predict from little videos like that of what this person is likely to feel. Um, and from that, now we can sort of reach inside of people and extract their hidden feelings. And so you can use this, and companies claim to use this to say, understand what your customers feel, even if they won't want to tell you, or use this to see if you deserve to get a job at a certain company. Um, but there's a kind of problem with that underlying approach, which is if you look at 30 years of research in effective science, we have pretty strong evidence that you can't do that. Um, you can't reliably predict what somebody feels inside from these decontextualized expressions. There was a paper in 2019, Lisa Feldman Barrett, Stacy Marcella, you may know, was involved in that as well, sort of summarizing that research. And when that paper came out, I think many people read that, and particularly ethicists and regulators read that, and they decided, oh, well, most of what effective computing is doing is useless and dangerous, and therefore it should be banned. So 2019, a group called AI Now came out and said the number one concern of AI in that year is that we should ban effective computing. And they actually quoted me as part of that report. And then more recently, the EU AI Act came out and prohibits the use of emotion recognition systems in certain areas like education, law enforcement, and the workplace. Um, so that's sort of the prelude. Now, so what I want to do in this talk is first, I want to argue that this kind of standard straw man model is still very pervasive in the affective computing community with occasional qualifications. And I want to kind of review why this model is problematic. And basically, I'm going to make 4 points. One is that facial expressions and other expressions are inherently ambiguous and contextual, that how they're labeled will change dramatically depending on the perspective of the annotator, um, that expressions and their meaning is co-constructed in social situations. And thus, it's best to view these expressions as communicative acts, not as felt emotional states, at least in social settings. And therefore, some of the criticisms made against the field are actually drawing the wrong conclusion. It's not that effective computing or motion recognition is dangerous and useless, but we need to be a little more careful in how we're promoting and how we're using these methods. And also, there's value in rethinking what the input and output of these systems are actually giving us. Um, and kind of a general theme you'll see throughout this talk is I'm going to try to emphasize why, as computer scientists, it's useful to know a little bit about emotion theory. Okay, so is this sort of standard model still pervasive? Well, one way you can look at that is to see what people are publishing on. And so recently, actually, the version of this talk I gave at the Face and Gesture Conference, it's one of the IEEE conferences that does a lot of work on emotion recognition. And so we surveyed the papers appearing in that conference to see what are they doing. Almost 90% of the papers that appeared in this year at Face and Gesture are annotating emotions from a third person perspective. So they're not necessarily getting what the person actually says they feel, but what the perceiver thinks they feel. And then about 80% of these papers are looking at expressions out of context. Just taking the face, showing that to an annotator. So that's essentially the standard model that I showed you before. Um, so I'm going to walk through why that's problematic. And the first point is that context matters. And I'm going to return to this paper by Lisa Feldman Barrett. And I want to emphasize, although it's kind of led to all this concern and ban on the field of effective computing, it's actually making a fairly narrow and specific point, which is that if you're an observer, a third person party, you cannot predict what this person feels just from the face without knowing anything about the context. And in fact, if you see the context, it can dramatically change your interpretation of the situation, including things like what are the other parts of the body doing? Same expression can be viewed as quite different. And therefore, you can't just from the morphology and timing of a facial expression alone make a reliable prediction about what that person is actually experiencing. So let me return to this video I showed you before and give you a little bit of context. So this woman was actually playing a game. It's called The Prisoner's Dilemma. And in this game, there's a pot of money that sits on the table, and then she and her partner secretly decide, do they want to try to split it or do they want to try to steal from their partner? Uh, and in this particular video, her partner just stole all of her money. Um, and so now that you have a little bit of context, I want you to kind of revisit your opinion, watch this video again, and you might actually see she's almost saying something with her face. Okay, so now if we take the same video, again, upload it to Mechanical Turk, get 40 people to rate it, now you see that context has dramatically shifted their interpretation. So where before almost everybody thought she was experiencing joy, now about an equal number of people think joy and anger or disgust. So the good news is that as a field, we're now beginning to recognize the importance of context. And so now there's a number of papers out, there's a number of data sets out that allow kind of a standard machine learning approach where you can learn from both the expression and the context. In our group, the way we kind of approach this is to build on social science theory. So we look at, well, what does psychology say about how humans make inferences about someone feels? So how would an observer infer a person's emotion from an expression and context? And the theoretical work and empirical work in psychology argues that basically people utilize context. So they have kind of a folk theory of how emotional expressions occur. So people generally assume something in the world produced an emotion, and that emotion then leaks out through a facial expression. And therefore, if you think of this like as a Bayesian causal model, you can look at the situation and the expressions essentially as independent cues to infer the underlying emotional state. And so adopting this theory, you can basically decompose the problem of how people infer emotion of other people from, on the one hand, people look at the expression and make an inference about what they're feeling from the expression alone, which is kind of the standard effective computing approach. And then people look at evidence from the situation and make an inference about what someone in that situation would likely feel. And then using Bayesian inference, you can combine those two probability distributions and then make a contextually informed assumption about what that person likely feels. And so my student Ben Han has been basically trying to translate that psychological theory into a computational model. And so what we do is take sort of standard emotion recognition techniques that can make a prediction about what that person is feeling from the expression alone. Um, Actually use large language models to reason about what emotions people are likely to feel in situations. Combine that with Bayesian inference, and turns out it does a pretty good job. So just to show how do we test this in practice, we go out, get human annotators, have them annotate expressions from the face alone. That gives us a distribution of emotions across a number of videos. We give annotators description of the situation alone, um, and have them annotate what emotion someone would likely feel, for example, if their partner stole from them. And then we get a third set of human annotations where we provide the humans both the face and the context to get the annotations. Um, and the question is, can we predict those context-based annotations from those face only and context only? And in fact, we can. So we use various automatic facial expression recognition tools to predict what emotion this person would likely feel from the face. We use various LLMs to predict what a person might feel from that situation. Uh, from just the situational description, combine that with Bayesian Q integration, and the best of these approaches actually achieves very close to human level performance in predicting what a third party observer would think that person is feeling from the face and the context. So general takeaway is that the standard model is to use decontextualized third-person labels of emotion, but in the real world, people interpret expressions in context, and this contextual interpretation is quite different than decontextualized inferences. The good news is that if we can decompose the problem into reasoning about context and face separately, we can still build on all these existing techniques developed within effective computing community. As long as we then integrate them with late fusion downstream, we can improve their ability. But the key point here is that we have to incorporate context into the reasoning. The second critique of the standard model is that the perspective of the annotator actually dramatically influences the inference. And so one of the concerns raised by ethicists about the use of effective computing is people are using third-person annotations to predict self-report. Yes, we can now incorporate context, but that doesn't actually solve the problem because third-person judgments do not necessarily correspond to first-person self-reports, even if you include context. And if you look at the psychology of how people form these inferences, we shouldn't be surprised. So from the first-person perspective, typically you're labeling it through introspection. You know what you felt, and you write that label down. If you're a second or third person perspective on if you're engaged in this task and making an inference about your partner, or you're a bystander looking at the situation, you don't know what they feel. You're doing it through inference. So those are quite different processes, and so perhaps not surprisingly, they could give different answers. There's also differences between how second person and third person people form inferences. Also, people engaged in the task are much more likely to be involved in attending to what's going on, whereas when you put people on Mechanical Turk, there's low involvement, less understanding of the context. And there's also differences between second, third person in the sense that if the expression is directed at you, it might be seen as much more intense than if you're observing someone else having an expression pointed at them. It's also, if you understand how emotions arise in people, differences between perspective or should also be obvious. So appraisal theory is basically one of the major theories of explaining how emotions arise in people. And the argument is that people appraise how a situation impacts their goals. So let's say a person failed their first math test as a physics major. Uh, the theory is that they would have some kind of goal, like if they wanted to get an A, we would assume that they would view that situation as negative. They would be sad. But let's say we learned that, in fact, this person didn't want to be a physics major and they needed to prove to their parents why they should shift majors to music, maybe they would be happy if they failed that exam. And so what the challenge is that observers and LLMs, for that matter, must impute what the goal that person has. Uh, and typically what they do is they assume the most likely goal someone would have in that situation, whereas in fact, that person might have quite different goals, which would lead to discrepancy between the first and third person perspective. Also, individuals and observers have certain biases that they bring when they're facing a situation. So if you're depressed, you're much less likely to feel you have control or ability to cope with situations than someone who is optimistic. So if you don't realize the person is depressed, there could be a discrepancy between what they're actually feeling and how you're interpreting the situation from an observer perspective. And LLMs bring certain biases to this process as well. So the consequence here is that there's fairly low agreement between different perspectives. So, for example, there's a data set, there's a few data sets out there that have been annotated from first, second, and third person perspectives. This is one comes out of Korea where they had people engage in a debate. People showed various emotions during the debate, and then they retrospectively watched their video of their partner, labeled it, and had third-person parties rate that as well. They had access to all the words people were saying, so they have information to context, they have information to expressions. Um, and what you see in data sets, not just this one, but others as well, is very low correlation between first, second, and third party perspectives. And so if you're trying to predict what someone's feeling in the moment in this debate from what their partner thought they were feeling, you're not going to do a very good job. So consequences for emotion recognition is that this basically the standard model cannot reliably predict first person feelings from third person annotations, even with context. And in fact, there's now, I think, within our field, growing awareness, sometimes I would say apologetic, of this problem. So rather than saying I'm doing emotion recognition, you'll see papers saying I'm doing perceived emotion recognition. Um, Now, one thing I think it's important to recognize actually is you don't necessarily have to feel bad about that because perceptions can be incredibly important when it comes to social interactions. So to circle back to this example we had before, this woman is playing the prisoner's dilemma. She's showing expression. Let's say I want to predict her next decision from what happened before and what she's actually feeling or what her partner thinks she's feeling. Um, so it turns out that the previous decision is very important. So if she got screwed over, she's probably going to screw over her partner in the next round. The partner is probably aware of that. Um, we could try to see, can we predict what's going to happen from what she actually feels? And we can try to see what is likely to happen from what she appears to feel. What does the partner think she's feeling? Actually, turns out in this game, what people really feel is not very important for predicting outcomes. What matters more is perception. So, what people perceive their partner to be feeling drives their next action much more than what that partner was actually feeling. Um, and that's not surprising in many social tasks. So, in social interactions, perceptions often shape the decisions more than actual feelings. And this phenomena is, of course, known to marketing people and companies. So there's this idea of emotional labor. So employees must express certain emotions, even if they don't feel them, because we know it shapes the customer's behavior, makes the customer happy, makes them spend more money. And of course, this works with machines as well. So we can build machines which clearly don't have any emotions. But as long as the humans perceive them to be expressing certain emotions, it has important benefits for applications. Kind of popping up the main lesson, though, is that the perspective that we got on our annotations really should determine how we want to use the model that we learn. So if we learn, let's say we want to predict how someone in a clinical setting, are they depressed? Uh, then obviously I want to predict the actual depression, and so we need first person labels, right? If I want to predict how people behave in a social task, perhaps it's more important to predict perceptions rather than the actual feelings. And so really the key takeaway is we need to be very aware as a field is where these labels came from, what are their perspective, and that will help determine what's the best use of a model trained on that data. Okay, the third critique I want to make of the standard model is that emotions are and their meaning or emotional expressions and what they mean to people is co-constructed. So what do I mean by that? So if you look at most papers in effective computing, uh, we focus on the individual. So we look at a video of a particular person and try to infer something about what they might be feeling based on the timing, morphology of the facial expression. Yet many of these data sets are actually developed in a social context. So somebody is doing something together with another person. Um, and you can see this, for example, if we go look at the papers that appeared at the Face and Gesture Conference 2025, 75% of those papers were collected in a social context, and yet the vast majority only focused on the expressions of a particular individual. Um, if we're aware that this is occurring in a social context, it kind of raises the question, well, where does this expression actually come from? So here we see a woman. She shows a smile. We might ask, well, why is she smiling? Is it somehow related to the outcome of the tasks she's doing? So she, in this case, just stole from her partner. So we might think, oh, okay, this smile that we're seeing reflects her joy at defeating her partner on this particular round. Um, but it's also possible what she's doing is reacting to her partner's facial expressions. So this is the person she's playing. In this particular round, the woman on the left steals from the woman on the right, and this is what happens. So I think if you see that expression, you'll realize the smile is actually laughing at the facial expression that her partner just showed in reaction to the event. Um, And in fact, when you look at both sides of partners in this game, you see obvious synchronies between the facial expressions of different people. And that basically raises the question, where do these expressions come from? Do they come from the activity they're doing, or are they simply reacting to their partner's expression? Are they in a shared task? And how can we try to tease that apart? Well, one thing we can do is we can manipulate if they actually see each other. So it turns out these people on the left are playing this game, Prisoner's Dilemma, over a video teleconference. They're seeing each other's facial expressions in real time. The people on the right that seem to be smiling at each other are actually playing with the video turned off. So the fact that they're smiling together has nothing to do with the partner. It has everything to do with what just happened on this round. Um, and so we might then ask, for example, which is more synchronized, and does it depend on the outcome of the game? So the way we approach this is we can actually try to measure using a technique called dynamic time warping how synchronized each party is. And then we can create randomly paired dyads to see are people more synchronized than they might appear at random. Um, and so what do we see? So we see when people are see each other, or when people are actually dyads playing together, we see more synchrony when they see each other than when they don't. Uh, this suggests that part of the expression is they're reacting to their partner. Um, but even when they don't see each other, there's much more synchrony than these random dyads, which suggests that a lot of the synchrony we're seeing in these videos has something to do with the shared task. Um, so bottom line, it seems like expressions are shaped both by the task outcomes and the partner's expressions. Um, and that we see some influence of the task outcome on the level of synchrony. So people are more synchronized when they cooperate with each other. Actually, this difference is less visible when people can see each other. So in some sense, in this game at least, it's easier to predict what happens when the video is turned off. Okay, so takeaways so far. Standard view is that emotions don't denote some biologically evolved underlying bodily state that's inferable from the shape and timing of expressions. And what I've outlined so far is three critiques that these expressions are actually ambiguous and contextual, they change with perspective, and they're co-constructed. And if you're a linguist, you would understand this sounds a lot like the properties of language, of words. So words, it's like the word bank is ambiguous. It could mean a financial institution. It could mean the side of a river. Uh, and the meaning of it is sort of emerges from the construct and context and is sometimes co-constructed. So that leads to the kind of fourth critique of the standard model, which is when you see an emotional expression, is this actually revealing some underlying felt state, or is it simply communication? So the standard model argues that expressions are some involuntary cue to some inner process, and therefore they should be present whether or not there's anyone to see that expression. The alternative view, of which Alan Fridlin is one of the big proponents, is that expressions are intentional social acts, so therefore they should only be present if someone we care about is there to see them. Um, so what does the research say? This is one very nice study, I thought, to kind of tease apart that question. So what Kraut and Johnston did is they looked at people playing bowling. And bowling is an interesting sport because all the action happens where there's no people down there at the end. And then you typically turn around to your friends, and your friends are behind you. And so you can then ask the question, when someone hits a strike, uh, when they get a good or bad score, when do they show the expression? Do they show it when they learned what their score is, or do they show it when they turn around and face their friends? And so they put cameras on both ends. And then you can ask yourself, well, when do you think the emotion appears? And when is it most diagnostic of what happened? Um, Turns out when people are facing the pins, they don't show much at all on their face at all. And it doesn't matter whether they give a good or bad score. But when they turn around and face their friends, they show very strong facial expressions. And now we see a big difference between the expressions they show when they got a good score or a bad score. So this kind of suggests that the expression is not about the feeling, but more about what they want to communicate to their partners. And we've done some work with this as well. I don't want to go too much in details, but we had people play games, and we can kind of control how the game unfolds. And we looked at the facial expressions. In this case, we looked at friends versus strangers, and what we were able to show is how well you're doing in the game predicts feelings. So you say you're happy when you win, you say you're not happy when you lose. But when you look at the facial expressions only communicate whether someone's winning or losing amongst friends. Amongst strangers, people pretty much don't show anything on the face. So it's as if they don't want to share. So within psychology, there's kind of a shift now in thinking of expressions that really it's better to view these things as communicative acts, not feelings, and therefore analyze them with the kind of standard tools we use to analyze language. So going back to our game Prisoner's Dilemma, imagine that you were trying to split with your partner stole from you, and then showed this expression of guilt. We can talk about the expression itself, which in linguistics would be called the locutionary act. We can talk about what was the communicative intent? Why did this person show guilt? In linguistics, we call that the illocutionary act. And so you might imagine that this person is trying to say, "Oh, I didn't mean to steal from you. I'll be better on the next round." And then we can talk about what the consequence of that emotion is from the partner. This would be in linguistics the perlocutionary act. So maybe that the partner, when they see guilt, they might realize it was a mistake, and they may accept that apology and try to cooperate more in the future. Um, so if we adopt this belief that it's communication, then that really kind of changes the way we should think about annotating expressions in these tasks. So right now, what we do is we look at that expression and we ask people, what did this person feel? Maybe it makes more sense to ask, what did they intend? Why did they show this expression? And also, if I saw this expression, what should I do next? Um, or we could actually not even ask people's opinions. We could just look in the game and see what people do. So when someone shows guilt following screwing over their partner, do they cooperate in the next round? Is it as if they were making an apology or not? Um, and so we've been trying to do that and understand how that works in social tasks by using virtual characters to simulate behaviors. So in this case, we designed agents that would show different patterns of facial expression based on what occurred in the game. We designed a cooperative agent that wants to signal that it has a cooperative intent. It wants to cooperate, and so it might, for example, if it steals from the person, communicate guilt, meaning, "Oh, I'm sorry, I'll do better in the future." And then we created another agent that tried to communicate a competitive intent. So it might, for example, when it steals from you, show joy to communicate, "Haha, I'm happy that I just screwed you over." And then we have people play these agents in the standard prisoner's dilemma task. So here, what you're seeing is a woman. In this case, she's playing a cooperative agent. Um, she actually screws the agent over. The agent shows it's upset with her. Uh, she tries to repair. She keeps cooperating, but the agent actually screws her back, but then shows guilt for screwing her over. And she actually accepts that apology, continues to cooperate, and they manage to reach mutual cooperation and do that for the rest of the game. And what we're able to show with various questionnaires and statistical analysis is what's happening is people are using the expression in context to form and understand the intent of their partner. And so they infer from that expression in context what's the expectation that their partner will cooperate on the next round, and then that determines their actual cooperative behavior. So people cooperate much more with the cooperative agent than the competitive agent. So general takeaway is what I'm trying to argue in this talk is that expressions are more like language, at least in social settings, uh, than an expression of an underlying physical state. That meaning is fundamentally ambiguous and contextual. The interpretation of those expressions changes with perspective. That meaning is co-constructed in an interaction. Uh, and thus, probably it's best to view these using the tools of language. Um, that shouldn't necessarily bother us because AI is actually pretty good at reasoning about language these days. I mean, that's fundamentally what LLMs are designed to do. Um, Now, just to wrap up, I'll kind of revisit this question about whether we should ban the field. Um, so within things like the EU Act and AI Now's report, the argument is that um, these are dangerous techniques that shouldn't be used. And what I want to argue is that the EU Act also, in a sense, assumes the standard model. So if you read the language and the justification around why we should ban affective computing and education in the workplace, a lot of the language implies that emotions are private states that people don't necessarily consent to reveal. And these algorithms, in some sense, are getting access to this privileged internal state. So it's really conceptualizing emotion as these kind of discrete internal states, like the Paul Ekman view. Um, what I want to argue is these concerns don't necessarily arise if we see expressions as language, as communicative acts. People are trying to communicate and shape their partner in a social interaction. And so if we prevent algorithms from reading that language, we're basically losing a lot of the what the person's intent is actually to be in this social interaction. That said, I think there's other valid concerns that are raised by this legislation in terms of things like bias and power asymmetries. Um, so just to kind of wrap up, I think what does this change of perspective mean for the field? I think there's certain important lessons. First is we need to interpret expressions in context, but we need to, if we want to really embrace that idea, we need to clarify, well, what do we mean by context? Does context mean other modalities? Does it mean the other person in the social interaction? Does it mean something about the joint task? And so that suggests a research agenda that really kind of formalize what are these different notions of context? How can we incorporate that into machine algorithms in the data sets that we collect? The other lesson is perceptions differ by perspectives, and so all techniques and algorithms should clearly disclose what was the perspective used to collect this data. And then when applying these learned models, we really need to think of as that perspective appropriate for the downstream task we're trying to accomplish. Um, Expressions are co-constructed. What that means is we really need to have corpora and methods that not just look at an individual in a social setting, but try to understand how those individuals are reacting and responding to other individuals and how that can change over time as the situation unfolds. And then finally, if we think that expressions are better seen as language, as I was saying, we really need to kind of think about annotating things for intent rather than feeling. And then we need, of course, to define a language of what we mean by intents. So that's all I got for today. We got a few minutes for questions. And of course, all the stuff I presented is not my work, but the work of the various people I've worked with. And with that, I'm happy to take questions.
Uh, Thank you very much, Jon, for a great talk and very important message for the messages for the community. And I'm going to clap on behalf of everyone. So I'm going to stop recording so that people can ask questions.